Hello, folks.
Oh,
Hello.
Hi. I don't know if there will be any other people outside the team joining. Let's wait for a while. Hello, Matt.
Hi there.
How are you?
Doing okay. It's yeah, feels like it's been a while since I've done much crossplane stuff. So
Nice to see you back.
yeah. Thank you for picking up the Terraform provider upgrade work.
Yeah, yeah. So we still have work to do there. We completed the bump to 5.50.0, but um, we had some automations around it, GitHub workflow that automates bumping the provider. And, when you run it, the remaining thing were validating certain resources and fixing the configurations if they are broken, kind of thing. But when we switch to the no fork architecture, the job is no longer relevant. It's broken.
Right.
We need to fix it. And also now we have a fork repository, and there are some other things that we need to carry on in the fork repository. So we discussed, some items with Fatih already, and as usual, we can also ask for help from you. But the idea is to adjust the existing GitHub job
Sure.
to the new architecture, and probably it makes sense to add a new job that prepares the release branch in the Crossplane fork, in the outbound fork of the Terraform AWS provider. And then again, we will have the same level of automation. So the remaining thing, so after we run those jobs, what's remaining is we have some tooling that detects breaking changes and configuration changes, that might be needed.
Schema change.
Excuse me?
Schema changes, basically.
Yes, schema changes and, the CRD diff job. We
Yeah.
also check for CRD schemas and also Terraform schemas. And then what we do is we test them. In our roadmap, we also have automating such things. If you can detect the schema changes, then we can automatically invoke Upjet
Right.
on affected resources. And if the tests fail, then a maintainer can come and take a look and try to fix and understand and fix what's going wrong. It's like that. So we have a long way to go still, but unfortunately, with the architecture change, the existing automation is no longer working. And
Yeah. It was sort of a step backwards in maintainability.
yeah,
Which is the sort of thing that's acceptable when you have a 2 orders of magnitude step forward in performance.
yeah. And that's also one of the reasons we are careful about what we put into our forks.
Right.
We generally weight the changes that we are planning to introduce into that fork. We don't want to make those forks difficult to maintain. So
Right. I feel like the adding that support case resource um, was definitely
yeah, it negatively impacts. So we can discuss, as usual, it's trade-offs in engineering. We are
right.
aware of maintenance overheads. But
versus what your customers want.
yeah, but implementing as a native resource has also major drawbacks. Like, when you implement a new resource using AWS SDK, let's say, it means that you need to write a new connector, a new external client
Yeah,
on top of the existing ones that comes from Upjet, right? Which means that when you have some cross-cutting features to be implemented that affect these, external connectors, clients, then it means that you also need to implement them manually. It will even manually for the newly added external connectors and clients. Uh, you know, if we can avoid this, our provider architecture stays homogeneous, and it makes then fixing bugs, adding new features easier in the Upjet and providers. So that was the trade-off. And
yeah,
the idea is like, when we introduce a new resource, we will also contribute to upstream,
right.
Terraform provider, and then we can get rid of, the custom editions in our provider with a version bump of the
Has
underlying.
someone actually opened the PR to upstream that support case resource?
Not yet, but
Okay.
just planning to open that PR.
Okay.
Yeah.
Um,
And if you follow those, the discussions around that resource, it turned out to be quite tricky. There was a reason it was not added in the first place. And, the upstream Terraform community followed a different approach. And that approach doesn't fit our model, like, the
got it.
cross model. So what they are doing is they're managing, uh, was it Kafka, Jem?
MQ.
Oh,
But
so
Matt is talking about support case resource. So I was going to add that,
Oh,
Matt,
I,
in addition to
okay.
support case,
Did we
we
add it?
now have
Oh,
a
we added
different resource.
another resource in our fork?
Okay, yeah,
We
sorry,
did,
sorry.
MQ user.
Yeah,
So
we removed, by the way, support case, but a new one came. Like, it's still.
Yeah, because I was like, wait a minute, the support case resource seemed like totally trivial and normal and straightforward, and
yeah, it was an easier resource. It just didn't support deletion and something else, I
right.
guess. It didn't
There's
support
we
deletion,
also, I
but
mean,
it's fine.
there's other resources that don't like. I added a resource that was already there
Yeah.
in the provider for what was MSK Connect plugin configuration or something like that. That like there is no delete API
Yep.
in the AWS SDK. You cannot delete it.
Such resources
There's also no
exist.
update. So you create it and then that's it for that name. And if you try and create something else with that name forever, it will always fail.
Mhm.
Yeah, so the trick with the MQ user, like, in the underlying provider, the what was it? I completely forgot the name. What is
MQ,
the parent?
AWS MQ broker and MQ
Okay,
user.
the
Which is
broker was
their like
the user.
managed ActiveMQ.
Yeah, so
Yes,
the
active
broker
MQ.
the broker resource was implemented in a way to manage its users also. So brokers and users are two, distinct external resources,
Oh,
and they are managing two external resources with a single Terraform resource. So,
got it.
and it's not good for our
Right,
resource model, as you know.
right.
So they should be distinct entities. Like, the changes that we implement, like, better suite the Crossplane ecosystem, and we will also see and explore, how they whether they will welcome, like, the changes that we'd like to introduce. So
That one may be harder to convince them to upstream. Um, I had a couple other ideas related to the maintenance. One was just like I wrote a couple of different scripts that did things like parsing the Terraform changelog for resources. Like they have a fairly standardized format for their changelog that includes like the resources, and it's like, okay, well, first let's ignore all of the ones that are data resources, and then let's ignore all of the ones that are resources that we haven't implemented, and then let's see what's left and like sort it by resource instead of just by version, so that we can, like, if we're bulking multiple versions. And I wrote that script, and it works, and was like a good way to like try and see what changed. There was another one that I did that was trying to make a list of framework versus plugin SDK resources, because I have a fear in the back of my mind that someday the Terraform provider is going to be like, we're just converting this resource from using the SDK to using framework, and it's a totally non-user facing change. So users of our public API won't even care. We're not even going to mention it in the release notes. We're just going to do it. And then that breaks the Crossplane resource without any like schema changes or anything else that's detecting that. So I don't know if I didn't see anything that was like trying to detect, like, is this resource still reconciled with this like framework versus plugin?
Because
the script I wrote was very like rudimentary, and like I think it was like looking for what package did you import in the file that implemented the resource or something like that, but it worked. So
yeah, so when they change the underlying implementation, like when they replace, let's say, an SDK resource with a framework resource, do we still compile, by the way? I guess so.
That's a good question.
Yeah, sure, we do. I mean, we will
so.
just change the external client that we are using. In the past, it would use the SDK client.
But the
now
question is, like, they
framework.
do this with, a new version of the provider, and we are not aware of this, and we bump the version. Right. That's the question.
So if we take, I guess the way to test this would be to take resources that are on the reconcile with framework, or reconcile with SDK, reconcile with framework list, and put them erroneously back in the reconcile with SDK list and see what happens.
Yeah, so I think we can give it a try. Like, if it's already broken, then that's good news, because it will not go on, unnoticed. That's why I asked this question.
By the way,
yeah, that's a good question.
Considering the code generation pipeline, it is supposed to be broken, because we maintain different external name configurations for SDK and plugin framework. Yep. When an SDK configured resource cannot find its schema in the returned SDK resources by Terraform, it will fail. It will fail with a panic.
The complication there's a complication there. When we introduced the new architecture, we introduced it with a minor version bump, not a major version bump. And, we also started following stricter policies around breaking APIs and such things. And as a workaround to make these changes backwards compatible, we had to continue using the JSON schema that we generate. So even if, like, a resource uses the plugin and framework to represent its schema and, to implement its functionality, the crude functionality, its schema is still serialized into JSON.
I know exactly the piece of code
and then we deserialize it back to SDK resource schema. So, if we were directly consuming the Go schema, then I would expect, things directly breaking at, compile time, at build time. But because of this indirection, like, because of us using the serialized schema, we might miss it. I'm not sure. We need to check it. But I think, like, this is a very valid point. Like, we need to check when we bump the underlying providers. So our existing tooling is not aware of this, because that tooling comes from the old times. Like, we did not need to deal with in
from
such
the CLI world
old architecture. So, it doesn't detect. The only thing, maybe if, code generation is broken or something like that, we might be able to detect. I'm not sure. So I think that's a valid point. And, the scripts you introduced, look for that, Matt. Did I get it right?
So I don't remember what. I have a whole bunch of open pull requests that nobody's ever reviewed. And many of them have been open for long enough that I've forgotten what is in what.
Okay.
So I remember writing a script that just like recursed through all of the file, like went and like looked at the I don't remember what exactly it did, but it was like it was a Python script. It was completely unaware of Go other than as a string. And I was like looking for the annotations that say this is an SDK
Okay.
resource, this is a framework resource, or something like that in the Terraform provider code base, just sort of to produce a list of these are all of the framework resources, these are all of the SDK resources.
Okay. We also have a file, that keeps record of the generated resources,
Yes, I have a PR that changes that
generated.ls
too.
or something like that. We could also enrich that file with the underlying, framework in use, whether it's the, plugin SDK or plugin framework.
I
And
have a
we
PR that reformats that file to use new lines, with the result that it stops having a get conflict on every single resource edition.
Okay. So
So
we can exchange, the syntax there.
I mean, it's a white space change. Like that, it's still machine. It's literally just like changing the way it formats it.
Okay.
There is an open that one there's definitely an open PR for, and it's a like one line PR. But the idea there was like right now, if I add one resource and you add another resource and my PR gets merged, now yours has get conflicts and you have to rerun code generation because of this file. And
Okay.
the file is so simple, get can absolutely handle merging it if we just put in new lines.
Okay. So since it's a single line, git detects,
Right.
change.
Because the whole thing is a single line. So it's like you change this line and you both change this line and I don't know what to do.
Okay. So there is a similar issue with config.json, by the way. So it's also a single line. And like, when there's a change there in schema.json, config/schema.json, it's difficult to detect those changes. And I think Jem is going to prepare, like, we discussed this with Jem, but we didn't implement it, right? So we are also planning to introduce something. So recently, Jared was introducing a change in the DigitalOcean provider.
Okay.
And there was some changes in the generated schema.json, and he was confused because it's difficult to understand, what has changed there. And I did the usual trick. I formatted it with JQ and, compared the files and, understood what has changed there. I think,
Have you used
that makes sense also. That definitely makes sense for generate.lst file. It also
yeah.
makes sense to, reformat schema.json also.
One tool I've used, started using recently, is diff, DYFF, which is designed for diffing YAML files. Of course, JSON is valid YAML. And it tells you things like if the only thing that changed is that the object, like somebody alphabetized the keys in the object, like it's like no changes detected. But it'll say like, these list items are all the same, but they changed order. Or one item was added, but like parses that as a
So
like with a schema
the
aware
name of
diff,
the tool?
basically, for diffing objects.
What was the name of the tool? Once again?
DYFF
Okay. DYFF.
for like it's like a YAML differ.
Okay.
Um,
So let me share my screen and let's go over the formal agenda. So this is after a long jam session. Welcome to the SIG Upjet meeting. This is June 5th, 2024. So let me start with what we have here. So I think this is an item that Fatih added. We are updating telephone provider. Oh, excuse me. This is telephone. Oh, okay. So,
Alper, I added
okay.
recently just to make sure that it is in the notes.
Okay. Okay. So
This
we
is what
already
we've been talking about
discussed
for
this,
20
right?
minutes.
So we bumped the underlying, telephone provider to 5.50.0. I confused this, by the way, the official telephone provider. When I read telephone provider, I thought it's like, the telephone provider.
With upbound/provider Terraform.
Yes, I confused with that. Sorry. So we already discussed this, and as we discussed, we need more automation to make bumping easier. And I expect that we will be investing in this because it's critical for the official providers. So we have another work stream. As you know, we are converting the singleton list to embedded objects. So these changes have already been rolled out for Azure AD, and GCP providers. The only remaining provider is provider AWS. We have an open PR that's under review and testing. Probably we will not be able to make this happen this week, but we should be able to do it soon. And what this final PR we will have completed, and all of the previous singleton lists in the official provider APIs will have been converted to embedded objects. We have discussed this in detail in the previous meeting, so I will not go into details. If you're interested, you can find, why we do this, discussions about why we do this in the previous meetings. But just an update, this PR completes it across the official providers. So there's another PR from Erhan, which introduces some end-to-end provider config tests for the AWS repository. It's also under review. I was personally willing to give it a review, but I couldn't find time. So any reviews are welcome. We would like to get this merged also, so that we can test our provider configuration changes more confidently. So we have a bunch of new resources, and we are planning to do a release of provider AWS, the official AWS provider, tomorrow with these changes, hopefully. There are also some other changes being implemented in Azure GCP and Azure AD providers. We already shipped some changes regarding the spec init provider API. So we were trying to introduce the MQ user resource that we discussed in the beginning of the meeting. And, because of some of the issues that I barely touched, during the introduction session, we decided to extend the spec init provider API so that secret references are also generated underneath it. So up until to now, before these changes, or let's say, non-confidential, non-sensitive fields were generated under the API, and the sensitive ones were missing. And in order to get certain resources like MQ user, use the spec init provider API, MQ broker to use the spec init provider API, we had to close this gap. You also need to be able to specify sensitive fields if, for certain resources. So we had implemented some changes in Upjet, and we had rolled out those changes in provider AWS, and there are a bunch of, there are 3 open PRs right now that roll out these changes, spec init provider API changes also for the remaining official providers. So with those changes, we are also automating, a task that we manually did previously. By the way, this also fits in the maintenance discussion that we did. Like, when converting these singleton lists to embedded APIs, Sergen discovered that, for some resources, there is inconsistency between the Go schemas and the JSON schemas. So this inconsistency was in the max items constraints. And what happens is, like, in the Go schema, there's a constraint on max items which sets it to 1, let's say, but you cannot find that constraint for the corresponding field of the resource in the JSON schema. And this inconsistency will result in a runtime bug. Previously, we just fixed these issues by manual configuration, which also means that, when you add a new resource, you need to be aware of this issue. You need to be aware that there could be some inconsistency here between these two schemas, and we may need to fix them. And, it's extra work to do when adding a new resource. So it benefits the maintainers to do this automatically, of course. And we introduced a change to do this in Upjet. And we are rolling out, the automatic configuration across the providers. And, for those providers that currently implement this via manual configuration, which are Azure and GCP, we are removing the manual configuration and replacing it with this automatic configuration. And the long-term plan here is to get rid of the JSON schema completely. So again, as we discussed this, just before we started the official agenda, but we had to continue using the JSON schema to prevent some, let's say, theoretically breaking changes. So practically, they are not breaking changes due to their nature. But from a theoretical perspective, like, float 64s are converted into int 64s, which is a breaking change, right? So in order to prevent this, we are still using the JSON schema, but, it complicates the implementation of the provider. And, like, it also complicates the features that we are adding, like, that because of us using two different schemas, we had to resolve a bug, like, this max items constraint bug. So it's our, in our best interest to get rid of the JSON schema and completely depend on the Go schema. There are also some, work, roadmap items in which we would like to, abstract this schema in Upjet and, not depend on a specific Terraform or HashiCorp implementation, whatever it is. But it's future work that we need to do. And, in the midterm, with a major version bump of the providers, we should get rid of the JSON schemas. And the last item is, we discussed this. So we have a PR in provider Azure AD that generates the secret references under spec init provider and introduces this automatic configuration of syncing, with the Go schema constraints with the JSON schema constraints. So regarding the spec init provider API, by the way, we have a bug that has been newly opened. It has been opened today. I triaged the bug and I could reproduce it. And I hope we can roll out a fix for spec init provider API soon.
This is wrong JSON path to get sensitive parameters? No.
Excuse me?
What? Which bug are you talking about? Wrong JSON path to get sensitive parameters?
Yes. Yes. I think I put a link there. You have seen it here, right?
Yeah, that's right. That's why I got the link from the agenda.
Yeah, this one. This one.
416. Yep.
hopefully we can roll out, the fix across the providers soon. So, since we did not, so the only affected provider right now is provider AWS, because it's the only provider that we rolled out the spec init provider changes. But there are open PRs for the other providers that have not been merged yet.
So you think that will be a 1.4.1 release?
Yeah, so I think we rolled out the spec init provider changes in 1.5.0, I guess.
Oh,
we
okay.
will need to, we will need to cherry pick this and do a patch release, which will be 1.5.1 provider AWS.
Oh, I'm confused by the title of the bug, which mentions 1.4.0, but that's the Upjet version, not the provider AWS version.
Yeah, I guess so.
Got it. Okay, that makes sense.
Yeah, so watch for that fix. The issue is, the IAM access key resource is right now not usable because, the resource gets created successfully, but after the first, during the first observation, because of the init provider changes that we introduced, a code path is broken. Let's put it that way. We need to fix it.
And does uptest fail?
Excuse me?
Does uptest fail on that broken resource?
Yes, it should fail. It should fail.
So
Updates should be able to catch it.
what can we do from a process perspective to the next question is why did we not test that particular affected resource or one of presumably the many others?
Yeah, because while we were validating this feature, we concentrated on the spec init provider API itself. So we tested, certain resources, but it turns out that for I examined the root cause of this, and it turns out that the access key resource declares a bunch of mappings that are completely ignored at runtime. So before the spec init provider changes were introduced, that resources mappings were were not being used in a certain code path. So maybe I can just show it from here. Let's go to APIs.
Could you zoom your screen in? The text is very
I will do. Sorry.
Thank you.
Is it
That's
better
much
now?
better. Yes.
Okay. So if you look at here, this is one of the methods that Terraform resources should implement. And as you see, it returns a mapping from Terraform paths to managed resource paths. And we do a bunch of processing using this map. And one of those processings is we try to read reference secrets and put their values into the objects parameters. However, since these are sensitive fields, the state set provider secret field doesn't even exist, or state set provider SES, SMTP password v4 fields don't exist. So I can also show it to you.
No, that makes sense why that wouldn't exist.
Yeah, so it makes sense, right? So these are sensitive fields, and we have not generated these fields, and these mappings, in fact, are useless from that perspective. So in the code path that I am describing, they are useless. And what happens is previously, when that code path was executed, we were just ignoring, these mappings because these fields under edge provider were just missing. The MR schema does not contain them, and they are useless. But with the recent changes that we introduced, even though they are useless, they are right now breaking reconciliation. So, something previously not usable or let's say unnecessary now became a bug. Let me put it that way.
Could
So we
we?
need to fix this.
I would love to have a uptest schema or uptest job or something like that that was some sort of reasonably representative collection of a bunch of different resources that do slightly different things, but all share the attribute of they are fast and cheap to create in AWS.
Yeah, so I think it makes sense. So
That we
this
can just
was,
run on every, like we could even have that run on like every pull request, like have that be a required check for every pull request if it's like
yeah,
fast, like
yeah. So, there are a bunch of, resources that we commonly test. User access is probably not one of them, right,
mhm.
Fatih? So I think
But
that makes
because it's
sense.
presumably fast, it could be. Like now that we know that there's something special about this resource, that could then go on that list.
Yeah,
I don't want to test every resource under the sun. That will be both
yeah,
very expensive and excruciatingly slow, and all kinds of things will fail. But if we can say, here's a this is the nice list. We don't have to put every single resource on either the nice list or the naughty list, but we can say, here's a list of things that are stable, reliable, and fast and cheap, and like prepare a manifest that can test them all at the same time, so we don't have to like run a dozen different Upjet jobs that are each going to try and stand up a kind cluster and compile and like deploy their own VPC and whatever. Like we could have one job that has names that don't conflict with each other that can just go apply a manifest with, you know, a couple dozen resources or something.
yeah, yeah. So I think that totally makes sense. But the question here is like, we implement the change in Upjet, and it has some implications on AWS resources. And how can we detect bugs that we introduce with Upjet changes? Like, the common theme that we employ here is we generally test a subset of resources, that we can detect and are affected by that change. So this resource, for example, did not seem special,
Right.
and it just skipped. So no schema changes. Like it of course had some schema changes because maybe it didn't have any schema changes. I'm not sure. So it depends on whether there exists a sensitive field. So let me check it. It could have, but I'm not sure. So probably it has because this secret should have changed that. But like there are.
I would expect it to have secret fields, but only in computed values, not in parameters.
Yeah, so the init access key init parameters does not have secret references. So with that change, the schema of this resource didn't even change. So
Yeah.
apparently, it was not a configuration argument. It was a states attribute, like the
Which
effect, the secret at states at provider. So what I'm trying to say is, for example, if there was a sensitive configuration argument inside this resource would have a schema change, and it could potentially be under our radar, right?
yeah,
But unfortunately, this resource didn't have even like a schema change. So if we could envision this code path, we could have already prevented this bug. We were not aware of this code path
well
when
that's why I want to have a like standard, here's a bunch of different things that you run every
yeah,
time.
yeah. So
That
when
can
we increase the
complement the
number of
existing testing
resources,
approach.
yeah, when we increase the number of resources that we test, we will increase the probability of catching bugs. So it's a general, it would be something general. But I like that way way of thinking. So when a bug happens, we think like, whether we can enhance our tests in a way so that we can
Yeah.
catch it. For example, the thing that I mentioned again in the beginning, like, when we detect schema changes, we can automatically trigger up test runs on them is one of these, improvements that we can make. Uh, So we need to fix this bug. And like, regardless of whether we could have run up test automatically on this or not, an up test run will catch this bug. That's the good news. So,
yeah, that's great.
Yeah. We also introduced a new late initialization configuration. That's the next item, 2.b. So in Upjet, we have automatic late initialization, which basically observes the external resource and can populate spec for provider fields that are not set. And from time to time, we need to customize how the late initialization library works. So when introducing again the MQ user resource, there was a need to extend the configuration capabilities of this library. So the idea was, this one. So the idea is, so this is quite generic, by the way. If a configuration parameter is specified under spec.init provider, then we should not be initializing the corresponding parameter under spec for provider, because if the user of our API has explicitly given a parameter under spec.init provider, it probably means that he doesn't want it under spec for provider, right? But currently, since the late initialization library, is working in completely in automatic way, it just, observes spec for provider. It sees that, that field is unspecified there and it initializes it. So the problem with the MQ user resource is the way it was meant to work is, you would give what we call as bootstrap users, brokers, bootstrap users under spec.init provider. But Jem quickly figured out that, when we do so, the spec for provider user, array also gets initialized. And this was breaking, the scenario that we are trying to implement. So in order to overcome this, we had to enhance, the late initialization libraries configuration means by saying it if this field is already set under spec.init provider, do not late initialize it for spec for provider. So in my opinion, we could roll out this change as a generic configuration, part of the default resource definition of Upjet, because of the reason that I mentioned before. If somebody gives a parameter under spec.init provider, I think we should not be late initializing it under spec for provider. But we did not do this generalization. And, currently we just configured the broker resources, user field in this way. As I mentioned, we can consider generalizing this across all the official providers, and probably other maintainers will also benefit from it. This is already in, and we configured the broker resource using this new configuration facility. But we would also like to do some more further generalizations for the late initialization library, because there are a bunch of other cases, we call them categorical errors. There are certain fields in the, Terraform resources that are mutually exclusive. So the Terraform resource declares that if, the configuration argument A is, specified, then B should not. And if B is specified, then A should not. They are mutually exclusive, right? And currently, on the Crossplane provider, when you set the configuration argument A, then we late initialize B. And upon the next reconciliation, Terraform finds out that both arguments are now specified and results in an error at runtime. So we generally catch such errors, you know, when we are introducing new resources, but we cannot catch all of them, you know, because we cannot test all of the configuration space. So even when we are introducing a new resource, you know, we may not be able to test, you know, certain configuration argument nested deeply nested, for example, in, you know, in the API tree. And, you know, whenever somebody sets it, then we will become aware of the bug. But like, you know, we can prevent this because there are already some hints that we can use in the Terraform schema. And like, you know, if we have some generalization, some new, like, you know, configuration facilities for the late initialization library, then we can convert those Terraform schema constraints into, you know, configuration of the behavior of the late initialization library, which will prevent such categorical errors. So this is also, you know, in our roadmap. And like, you know, this PR was one of the first items that we implemented for that roadmap item, and we would like to continue those generalizations. And this will help us in maintenance and, you know, providing future bugs.
I remember a while ago, Jem mentioned that when he was going through and implementing the no fork architecture, I forget if it was for framework or for SDK, that there were some things that were just like flat out impossible to reconcile between init provider and fork provider. And that maybe there would need to be some reconsideration of the like design of the init provider API. And I haven't heard anything about that in a while. I mentioned that, I think I mentioned it at one of the Crossplane meetings, and somebody, it might have been Nick, it might have been somebody else, was like, hey, I was one of the people who was originally pushing for the difference between spec and net provider and ignore changes. So if we're going to change that decision, I want to be involved. But has anything happened on this? What, I don't know any more details. I'm curious.
Yeah, nothing happened since we talked it in our Upjet meeting, Matt, but I don't know the other meeting. But I don't remember having any updates under the discussion of putting init provider to GA. Since then, we've been busy with other stuff. For instance, even adding this MQ user resource turned out to teach us something about init provider. Previously, no one has ever needed any secret field inside init provider, and turns out it is a useful field indeed. So yeah, I guess we need more time and more headspace perhaps to work on finalizing init provider to GA.
The biggest pain point for me for a init provider is the combination is that when I want to normalize an external name configuration, especially one that previously did not set any identifier fields, into one that does have identifier fields, then that removes those identifier fields from the init provider spec. And then now that is technically a breaking schema change, even though it never really would have worked without like the old way, because the fields are required and it just will break at runtime instead of at compile time. And I mentioned this in so I have a PR open to add support for the EKS Access Entry and Policy Association. And I have put a couple other sort of more general comments in there as well, around init provider. Like I realized that formatted identifier from provider doesn't set any identifier fields, even though it uses them exclusively to construct the external name, which seems like that's probably just a bug. But if I fix it, now there's a dozen resources with fields removed from their init provider. So I've got a couple of ideas of things that could help with that. I think it would be great, especially if we're planning on releasing. I assumed we weren't going to release another version for another month, but I know there's several people who've been clamoring for this, the EKS Access Entry and Policy Association resources. So it would be great to have that, to be able to get that released. The only thing that's failing right now is the linter, which just runs for an hour and then times out or something. But what I'd love to get eyes from somebody else on this PR, and also just sort of what do you think about this in terms of the interaction between identifier fields and the other one is immutable fields. Should an immutable field be in spec init provider or not?
Yeah, so your problem is, if I understood correctly, not putting identifier fields into the init provider, right?
Currently, if a field is marked as an identifier field, it is not put in the schema for init provider.
Yep.
And currently, we have dozens of resources with sort of naive external name configurations that were left over from when there was just an army of contractors asked to go implement all of the resources. And they're not normalized, and many of them have identifier fields as defined as a field that must be defined even for an observe-only resource because it's used to construct the external name, but they are not in the identifier fields array because it's just using spec.identifier from provider or like some other, or even if it's using formatted identifier from provider, that one doesn't put in any, that one doesn't declare initializer, identifier fields. So the act of normalizing the external name configuration, which is sort of a net improvement, results in removing fields from spec init provider, which is like technically a schema change. And then it's this sort of like, this is theoretically but not practically a schema change because it's just moving a runtime failure to compile time failure. So I'd really like to have a solution that makes those improvements easier to make in terms of normalizing the external name configs. All of the different external name configurations is definitely one piece that makes the Crossplane provider substantially harder to use for users, especially because they're not documented at all. And when I have literally told colleagues, like, the only place to figure this out is to go read the source code. And that feels a little bit embarrassing that that's the state of the documentation. So I would love to be able to have, to improve that user experience, but we cannot make any schema changes that might theoretically be breaking is that's making that harder. So I had sort of three options that I could think of. One was actually do include the identifier fields in both init provider and for provider and merge them somehow. One is go remove all of the immutable, something I proposed before, remove all of the immutable fields from an init provider in a new API version. And then the other would be, I think would probably be the best user experience, but also probably the most work, which would be make the identifier fields no longer required by having it be more flexible around, well, if the user specified an external name, then we can just use that. And if they didn't, then we can construct it from the parameters, maybe from either init provider or for provider or from the merged combination or something like that. But like adding additional logic to that external name configuration function that I know is already really complicated. But that would let users like as a Crossplane user, I would like to be able to just to not have to think about how is this resource's external name configured when I want to observe it. And right now, sometimes, well, if I want to observe it, first I have to figure out what goes in that external name field, which we could document with examples. At the moment, the easiest advice that I give is go create a real one, a full control one, and then see what it comes up with, and then use that format. But it would be great to just be like, no matter what the resource is, if you set the external name, it'll work. It would also be really great to be able to say, to not have to set the external name at all for resources that don't have a provider generated component, so that I can say, I want there to be a, I'm blanking on a particular resource kind, the IAM role, whatever. Like I want there to be an IAM role that has this name. And I don't care if it already exists or not. Go make it so. Feels like sort of that's almost the raison d'etre for Crossplane in terms of that like declarative, I just want it to be like this and I don't care how it gets there. And so I guess I think that like whether that's for observation or for creation currently requires different steps for different resources. I'd love to be able to make that more uniform.
And maybe a few comments on my side, like, we talked about backwards compatibility when, normalizing the external names. So, as you know, it's not just the CRD API changes, like, CRD schema changes that will break it. If we change the syntax of the external name annotation, like, then it's also a breaking change. So we introduced a couple of mechanisms, like, I'm referring to these multi-version CRDs, etc., that can handle like, convergence between a non-normalized external name syntax with a normalized one. But let's also consider that, like, it's not just what goes in and out of init provider, but also the syntax change itself is also a breaking change if you do really normalize the external name syntax.
Many of the changes that I've tried to make have resulted in the exact same string being used as the external name, but constructed differently.
Okay, so as long as the syntax stays same,
yeah,
we should be fine. So
not all of them.
certainly
There's
in the past
others
we
that would
did
be
some, like, configurations that preserve the syntax, and we can just roll out them without any further consideration.
But many of those currently remove fields from init provider. That's the obstacle that I've run into.
Yeah.
That's why I'm talking about that part without the.
Yeah. So one of the things is, we should be careful about, those breaking changes, potential breaking changes when normalizing APIs. But I agree, So there are two types of normalizations that we talk about. One is the API normalization, like, being able to remove spec for provider name in favor of the external name annotation. And, this is also mandated by the cross-plane resource model because, according to the cross-plane resource model, the source of truth for naming external resources is the external name annotation. It's not an arbitrary field or a name field under spec for provider. So when we talk about the API normalization, we are generally referring to, removing the naming fields from spec for provider and instead using the external name annotation for that purpose. We also have a second category of normalization, which is normalizing the external name itself. There could be a required parameter under spec for provider, which cannot directly name a resource, but it can become part of the external name syntax. Then, we may be able to remove that parameters value from the external name annotations value, because when we are constructing the identifier, we can construct it using provider config parameters, spec for provider parameters, and also the external name annotation. We can construct them from these information sources. So if one piece of information can come from spec for provider, then it looks like, we can normalize the external name itself so that we can remove. It's not, visible in the external name itself, but we can construct it from there. So that's the external name normalization when we talk about it. Regarding documentation, there is definitely, it's missing. It's really difficult for people to figure out what to set, what they need to set in different scenarios, right? So, the management policies makes the topic more complicated, because with the management policies, certain arguments that are required for provisioning, for creation, are no longer required. So they are the non-identified required fields that I'm talking about. But if you are trying to observe, if you are trying to create it, you need to supply them. But if you are just willing to observe them, then you do not need to supply them. And then comes the question of, what's the external name syntax? Okay, I need to set, some spec for provider or init provider fields, but then what do I need to put into the external name annotation, right? So those things are currently not available in the marketplace. We plan some, again, roadmap items regarding this, because I also feel not, good about it. Definitely, people needing to figure out, give it a try, trial and error,
Right.
or read provider code and, such things. And regarding the spec init provider removes that you are talking about, the context is the API normalization that we can do. I think it's fine as long as, if it's not already working as you described, even if you set them in spec init provider. I did not understand that part well. I think I need to check the PR or the discussion that you are referring to. Maybe we can put a link into this document so that, we can easily find it.
I can try and find a specific example of that.
Yeah.
I remember there was one resource I was implementing a long time ago that I had a little bit of back and forth with Fatih about, and he was pretty firmly of the opinion that we just can't remove things from spec init provider, even if they previously weren't working.
Yeah, so if they're not, yeah, okay. So let's maybe,
but I don't remember all the details. I don't even remember which resource that was. I could probably go find it though.
Yeah, so that would be great, Matt.
Can somebody review the EKS Access Entry and Policy Association PR?
Did Fatih already review it?
No, no one has reviewed that one. number 1273.
Okay, so I would suggest putting a link there, and we can prioritize it probably.
Where should I put the link?
So I think any other topics that you'd like to discuss?
I'd love to hear more about Chainsaw. I had a couple other things I wanted to ask about. One was I was recently looking at the Pulumi AWS provider, which seems like our provider is code generated from the source code of the Terraform AWS provider with some changes. And several months ago, it uses an Apache license, so I don't see any it shouldn't have any like copyright issues of us adopting some of their patterns. And or maybe it's MPL, I forget, but they switched from using a fork of the Terraform provider to just maintaining a list of patches, of Git patches committed to their repo. And which seems, I kind of like that as a cleaner approach, even though like it's more like the 1990s model of source control of people emailing patch files around. But it puts everything in one repo, so we don't have like our changes for our fork of the Terraform provider have to go in this repo, and the other thing, like it seems like it. And like the other thing that they do is that they are releasing a new version of their provider every time there's a Terraform provider, usually within like a day. So they have a very automated upstream provider bump pipeline that I think we could learn from in terms of easing some of the maintenance burden. I haven't looked at it in detail of like what exactly they're doing in their various patches. It looks like there's some things where it was like I saw some things that were similar to what we had in terms of we need to expose this publicly. I saw some things that was like we are reverting this change that was made upstream because it breaks something on our end. And I guess those were the two categories that I saw. But I think something like that might end up being more maintainable. Just something to consider.
Yeah, so if you are going to take a look into this,
I mentioned this in the Slack channel, the provider AWS maintainers Slack channel a few days ago.
Okay. So one thing, that you can focus on is the external name configuration. So we have this external name configuration in which we break Terraform IDs into, multiple places, like, some into secrets, some into spec for provider, state set provider, whatever, like, we break it and we need to reconstruct it back, right? So, like, when looking at the Pulumi implementation, maybe you can also consider whether, we can find a way to automate this. So the main hurdle that we have currently when we bump the underlying provider version is like, we need to test resources because the external name configuration might have been affected. Like, we might have introduced bugs if we don't change the external name configuration as is. So we may take a look at that. Like, if you are planning to do a comparison. I think, you know, it's very worthwhile to learn from them.
Yeah.
You
And
may also
I
like,
haven't
you
looked at
know,
what their test pipeline is yet.
yeah.
Because that's also obviously a huge component.
Yeah. So it looks like to me like, you know, we can automate the bump process itself. Like, you know, we discussed in the beginning, we already had this automation. And, you know, after that automation was run, the remaining thing was, you know, testing resources, like, you know, seeing whether they're still working, the effective resources, I mean. And, you know, that's mainly comes from our external name configuration. So we are touching some internals there. And since we are touching those internals, like, you know, the telephone provider might have just changed them and we might be affected, but, you know, we might just miss them. So
this is the price we have to pay for
yeah,
violating their, this is not a public API.
yeah. So, I mean, like, you know, in the previous architecture, still we had these external name configurations. So the task of splitting ID and trying to put it back complicates things on our side.
Yeah.
So this has been much of a debate among us, like, you know, and the identifier from provider has its strengths here. Like, you know, if you just use identifier from provider, then we are transparent to what Terraform provides us, right? So that's why it's a much more robust external name configuration, but it results in, you know, external names and APIs not normalized and not fully conforming to XRM because, like, you know, if you use identifier from provider, then you might be leaving some naming fields under spec for provider, like spec for provider name and things like that. So there's a price that we pay there. And, like, you know, it would be great to have better automations, even, like, you know, we can improve the tooling. So the improvements that you described, like, you know, parsing the change log or trying to understand whether a resource was moved from, you know, an SDK implementation to framework implementation. Like,
And I haven't yet seen that happen. I'm a little bit surprised that I haven't seen any examples of like this was an SDK resource and now we're updating this to framework. I've even seen some new resources that like the EKS access entry that I'm adding, despite their stated policy of all new resources must use the framework, these are new resources that use the SDK.
Yeah, so that's also my observation. So generally, if any new, you know, framework resource pops up, it's a new implementation instead of one being converted from SDK to framework. But theoretically, it's possible, right? So
It
that's
seems
also
like
what you described.
it seems more than possible. It seems desirable
Yeah,
from the
so it's
perspective of the
also
Terraform
they are
provider.
encouraging the framework. So
And it's
that's
I mean, it seems
increases the
better.
probability. Yeah, definitely. So, you know, I think, like, you know, we at least we should improve our tooling so that we can detect such changes. And, like, you know, there are some hurdles, you know, technical difficulties like this external name configuration and things like that. So we need to consider, like, you know, to streamline version bumps. So I feel like, you know, you are interested in implementing more streamlined version bumps. And I think, like, you know, it's an area that we definitely need improvements. So we were at a better place, and when we switched to the new architecture, we are now at a, you know, place that's not as good as we used to be in the past. But even in the past, like, you know, because of the complications of this external name configuration and things like that. So, you know, that process is not that much smooth. So one of the things that we need to consider, like, you know, let me give some more context there. A change that's not breaking for Terraform can potentially become a breaking change for the Crossplane provider. So that's why we check the Terraform version schemas in order to see whether there are schema changes in the underlying resource. Because, like, they can ship such resources with their conversion functions, so that, like, it's not a breaking change for them. But because of these external name tricks that we are doing, they become breaking chains for us. So, but if you remember, in provider Azure with version bumps, we usually deal with capitalizations, right, Fatih? So they're normally not breaking changes for the underlying Terraform provider, but it affects the external name syntax that we have. And, we cannot construct them properly because, those capitalized strings are hard-coded into the external name configuration, and we cannot handle them without making a proper update. So we track them with the version schema changes. So Terraform folks also rely on them to invoke the correct conversion functions. And we detect them, but there's a manual process to adjust the external name configuration with those changes if the external name configuration is not identified from provider, by the way. So identified from provider saves us in these situations, but it contradicts with the cross-plane resource model if the API is not normalized. So if you are going to take a look at those fields, I think it's very worthwhile. But please also keep in mind the external name configuration justification adjustments that we need to make.
Yeah, I'm not. I have. There's two parts of the like philosophical, like XRM type normalization that I'm not completely sure I totally agree with. That I kind of would like to learn a little bit more about why this is a good idea. The one thing that I've seen fairly frequently is that there is the name of a resource in AWS that has some sort of naming convention, regex, that is different from what is a valid metadata.name for a Kubernetes resource. See you later, Fadi. Thanks. And so in this case, when we by default initialize the external name from the metadata.name, like I'm thinking of, there's one resource I'm working with right now that's a AWS IoT topic rule. And it has a spec for provider name, and it uses the name as identifier external name configuration. But you can't put dashes in the external name. You can only put underscores and capital and lowercase letters. But you can't put underscores or capital letters in the Kubernetes name. And so the only casing convention that works for both of them is what I like to call everything smushed together case, or undifferentiated lowercase, which is not very readable. And so I end up basically every single time I'm doing this, I'm explicitly setting the external name, because this spec provider name field, which would have been useful, was removed. Is that just yeah, this, in that particular case, it would have been better to have them as separate fields. It's just someone going through mechanically adjusting a whole bunch of resources said, oh, there's a field called name, let's use it? Or is there like a philosophical reason why it's good to have those names match, even though they have different regex validators, that I'm missing?
Okay, so there are two things that I'd like to mention. First one is, as you also mentioned, you have discovered, like, even if you remove spec for provider name, and, like, even if you have the initializer, which sets metadata name as the external name, external annotations value, you can still specify like, a different name explicitly via the external name annotation, and the initializer will no longer overwrite it. Like,
Yes.
there's a technical solution in these boundaries. But in such situations, I personally think that it's okay to leave the naming fields, like, So there are examples of it, to the best of my knowledge, in the provider repositories, where we did not remove a naming field, like, because, the resulting API is not intuitive and, more difficult to use, sort of thing.
Is that the sort of change that I could go change back and go introduce the spec for provider name, keeping the actual format of the external name consistent, but making it come from a different place?
Yeah, so you mean in an existing in an
An
existing
existing
API,
resource.
right? So
Yeah.
you'd like to introduce spec for provider name back
Mm-hmm.
for this purpose. So, when you do that, uh, you need to consider backwards compatibility as always.
Right.
So I personally avoid, if the API is already there, I personally avoid it. But like, these are good candidates for major version bumps. Like, with major version bumps, we can introduce such changes in a more flexible way. And also in this specific case, like, if you introduce a new field, a new optional field, and, you can do this in a backwards compatible way. That's what I'm trying to say.
Yeah. Could
Yeah.
we get one thing that I'd love to be able to do is have a tag that we can put on open pull requests as come back to this when we're ready to do a major version bump.
Yeah, could be.
And because frequently what happens is I encounter something, I'm like, oh, okay, this can only happen in a major version change. And then I either don't do it or forget about it, or and then sometimes like even when we did the major version, the like version 1.0 release, it was like in a great big hurry, and then all of a sudden it was released, and I was like, oh, but like I didn't have a chance to include anything that I wanted to include in a major version release. So I think having a tag like that would be helpful.
Yeah, I agree.
I bet I have permission. I can just probably just do that. I can probably just make a new tag.
Yeah, you should be
Yeah, you
able to
should
do
be
that.
able to.
All right,
Yeah,
I'll do that.
so we have this breaking change tag. We generally use it, like, but theoretically we should not be like, doing minor or patch releases with breaking changes. And I think it's a good idea to introduce, like, maybe we are at now version 1, and, we can introduce a new tech version 2. And,
Great.
I think that would be, that would make our lives easier and make us be able to keep track.
Cool.
So before leaving, there are two little things that I would like to draw your attention to make Terraform provider updates more automatable. We can use a feature of Git called re. We can use this one. What it basically does is to remember your merge from the past and apply it automatically upon new merge conflicts, so it can help us. And I also put here in the document, Matt, the code block I told about you, that whenever a resource is moved from plugin SDK to plugin framework, our code generation pipeline should fail. You
Great.
can find it in this code block here.
I think that's good news, by the way. At least they will not
Me
go
too.
unchanged.
Yeah.
Yep, that was like I'm afraid that this will break, and I'm happy to hear that. I mean, I'm afraid that it will break silently. So noisy failures are much better than silent failures.
Totally agree.
Cool. Thanks,
So
guys.
thanks, Volk. Thanks, folks, for joining the SIG Upjet meeting. See you in the next meeting.
Okay. Bye.
Take care.